So Wednesday, man. We're going to look at our lesson for the week since we weren't here Monday due to the ice. We are not going to have a mandatory class on Friday. Not mandatory. If you need help with your program, I'll be in class. I'll have class on Friday. It's just not going to be mandatory for everybody. So we should be able to cover everything today we need to cover. No need to have class Friday. So I don't want to have class just to have class. I want to have class when you need to have class. And of course, I'm always there as an option when you need help. So that's what Friday is going to be. It'll be the optional class. Although I should make it mandatory for you folks that hadn't turned in last week's assignment yet. That's all right. You'll get it in. I know it's all this ice and stuff, and we just take it easy on no school days. That's right. I didn't open up my computer when it's not a school day either, so I don't blame you. Let's take a look at what computer programming holds for us this week as we get started back second semester. The program we had last week was not part of our curriculum. That was just to get you started programming again. It is for a grade. So it's just a very simple program. It is in Google Classroom with a template. All right, let's go to our grade screen. Last week was the Welcome Back program assignment, which was due on Sunday. This week we have decisions. We're going to look at our lesson on decisions, see what commands we learn. More decisions coming next week. After that, we got and, or not. The logic of that, followed by lists. And then we're going to have a project instead of an exam at the end of this. We do a lot more projects now as we get farther into programming. You'll have some program to write to show you can use decisions. So we'll be on that towards the end of February. So let's look at our decisions lesson this week and see what we can learn about Python. All right, 4.01. The power of if. Love it. To be or not to be. That's an easy yes or no. True or false, you decide. The power of if lies in your ability to make a decision. If the stove is hot, you decide not to touch it, hopefully. If you're old enough to vote, it's your choice to go vote. If you want to know what happens to Hamlet, go see the play. Or don't. You get to make that call. So you also get to write code that tells the computer what decisions you'd like it to make and when. So we're going to learn how if statements are used. If statements are very useful in programming. We're going to identify relational operators and use of Boolean logic for if statements. So let's take a look at if statements this week. So, sometimes you make decisions based on emotions or gut feelings, right? But other times you use logic. Well, computers don't have emotions and gut feelings, so they rely entirely on logic. So we need to work with that. Logic's one of the most powerful tools programmers can use. So the source of this logical programming power lies in one simple word, if. So if you always think in terms of a condition and a consequence, this lesson should be a cinch. So let's flip over each card to see what happens if the condition is true. So if you want to see a concert, if that's true, then you go buy a ticket and you go to the concert. Decision statements are based on condition statements. Start with the keyword if. If you want to go see it, you'll buy a ticket. If it is cold, and it is, you dress warmly, whatever that means for you. If the condition is true, then you take action. You put on a coat if you need it, gloves, a hat, whatever you need, long sleeves, whatever works. Depends on how cold you are. Condition: if you like spicy food, then you eat it. If not, you don't. Right? If that's false, if the condition is not true, then you do nothing and you just move on to the dessert. All right. So if. So it's very, very simple in that type of fashion. Page 3, relational operators. So this is the things we need to learn. How do we use relational operators to tell the computer to search for connections between items? So let's look at this. So let's see. If true, then what? So if your age is something 18, then you can vote. So that is greater than or equal to, greater than, equal. Now, remember in Python, if we're checking to see if something's equal to something else, we use two equal signs. Because when we use one equal sign, that's assigning a value, like number equals 10. That assigns 10 to the variable name number. So if we're checking something is true, we have to use two equal signs. Or less than equal to, or exclamation mark equals means not equal. Exclamation mark equal. So, of course, of this, if your age is greater than or equal to 18, you can vote. We don't want to put equal 18 because that means when you turn 19, you can't vote anymore. Greater than or equal to 18, you can vote. Submit. Yes, your logic senses are quite impressive. Let's look at the next one. If water is what? 100 degrees Celsius, it has reached the boiling point. We're not saying it's boiling, we say it's reached boiling point. So that would have to be when it's equal to 100 degrees, not equal and greater than, because it doesn't reach the boiling point at greater than. It reaches the boiling point when it's equal. So hit submit. It's a great job. So just going through these. The height, if the height is 48 inches, you cannot ride the roller coaster. And some of the really good ones are 54 inches. But if your height is less than, not less than or equal, once you hit 48, you can ride, right? If it's less than 48, submit that. There you go. I'm going to leave those other four. You can look at them yourself. If data usage is blank data plan, you pay an overage fee, et cetera, et cetera. I'll let you go through those. But let's talk about the if statement. So it tells the computer that if a certain condition is true, whether something's equal to something, whether something's equal or greater, or is just less than, or whatever it is, then the computer should execute the block of code that's inside the if statement. If it's false, then the computer just skips all that code and goes on to the next part of the program. So here it has an example. Height equals 48.5. If height is greater than or equal to 48, print you can ride. So in this, we would expect, since we set the height equal to 48.5, it should print you can ride because it's greater than or equal to 48 was the condition of the if statement. So take a look at the flow chart. You can see how it works. You arrive at the fair. If your height is greater than or equal to 48 inch, yes, because it's 48 and a half, ride the roller coaster. Otherwise, no. If you were shorter than that, you just go straight to no and go get ice cream. So either ride the roller coaster and go get ice cream, or you just go get ice cream. This uses Boolean logic. That's answers can be either true or false. There's no middle ground. There's no middle ground there. It's like, are you greater than or equal to 48 inches? Sort of. No. There's no sort of. It's like you are or you aren't. You can't be sort of tall enough to ride the roller coaster. All right, you're tall enough, you're not. Let's look at George Boole here as a little highlight on someone from history. He is the person who Boolean logic is named after. He lived back in the early 1800s, 1815 to 1864. He was an English mathematician credited with laying the foundation for the information age. He was the inventor of Boolean logic, thus why it's called Boolean logic, George Boole. He developed the basis for what computers now use to make decisions, the condition statement. Without him, you'd never be able to search videos with cats and teacup pigs or sloths. You're welcome. You can probably find a few videos of that. Cats and teacup pigs or sloths. All right. So you know I'm going to edit the video and put some of those videos in there, right? All right, precision and practice. It's true that the if statement is one of the most powerful tools a programmer has, but it's also cause of a lot of errors, right? If you're not used to thinking with Boolean logic, you're going to run into some confusing issues. But that's all part of becoming an experienced programmer. The more you practice if statements, the better code you can write. So let's take a look at some sample programs here using if statements. All right, here's the if statement. Define main. So this starts our program. Define main. That's what we do to start our main program. We're going to set A, which is a variable, equal to 20. And B equal to 30. So we've defined two variables and given them a value. Now we have this statement that's going to print to the screen. Facts about A and B. Now we have 3, 4, 5, 6 if statements. All right. The first if statement says if A equals B. Notice we had to use 2 equal signs because now this is Boolean logic. Up here we just use 1 because we're assigning a value. But when we check to see if something's equal, we have to use 2. That's one of the places you'll run into errors if you're not paying attention and remember that. So if A equals B, it will print A equals B. If it does not equal, it will totally skip this line and it will go to the next part of the program. Since if A is not equal to B, then it will print A is not equal to B. Remember, that's that exclamation mark equals means not equal. Then it says if A is greater than B, it will print A is greater than B. Otherwise, it'll just skip that. If A is greater than or equal to B, it'll print. If A is less than B or A is less than or equal to B. So looking at this, with A is 20 and B is 30, how many of these is it going to actually print? How many if statements are true? Well, this one's not true because A is 20 and B is 30. This is true. A is not equal to B. So we should print this one. A is greater than B. No, 20 is not greater than 30. So it should skip that one. It's not greater than or equal to 30. Should skip that one. 20 is less than 30. So it should print A is less than B and less than or equal to B. So we should expect it to print 3 lines there. So let's run the program. Facts about A and B. A is not equal to B. A is less than B. A is less than or equal to B. Okay, so that's how our if statements work. It skipped the print statements when the condition was not true. All right, so if statements are very simple. If it's true, it'll do whatever your code is. If it's not true, it'll skip. And notice, we indent to put that in the loop. All right. Here's another one. This is a very, very short one. This is the whole program right there. Define main. We're going to set age equal to 20. And if age is greater than or equal to 18, it'll say you can vote. So since age is 20, when we run it, you can vote. Let's experiment. Let's say you're 17. You're 17 years old. Oh, nothing in the outputs. We didn't tell it to do anything. If this is not true, there's no other code. There's nothing else it does. It only does something when that's true. Let's make it 18. Oh, you can vote again. Let's make it 17.995, like your birthday's tomorrow. Nothing, because that is not greater than or equal to 18. It's really, really close, but it's not. All right, let's look at this one. Now what have they done? Define main, number days absent. Num days absent. That's the variable they've named. And they set it equal to 0. And this says if num days absent equals 0, print you have perfect attendance. Let's see, let's run it. We have an error. Can anyone spot the error? Let me make that. If I make it bigger, it just squeezes part of it there. Something. Let's see. Does anyone know what the error is? I'm gonna open up the chat there. Look at the chat. See if anyone can spot that. Can you see what the error is? Why did they? You guys are on it. You guys are on it. Remember, we have to have 2 equal signs if we're checking a value. 1 means we're assigning the value. 2, so now when we run the program, you have perfect attendance. Like I said that's one of them errors that we'll run into if you're not paying attention. All right, fabulous. Fix the error. Slide number 4. All right, the if statement. Define main, starts our program. We're setting cost equal to 20.00. We're setting the discount equal to nothing, 0. On sale, we're setting that equal to Y. So we can check for numbers too. This if statement checks to see, does on sale equal Y? See, as long as we put it in quotes, we don't have to just check numbers. If it's greater than or equal to a number, we can check to say, does this variable actually equal this input, which is a Y? If so, then we're going to change the discount from 0. It was 0. Now we're going to say 2.85. Then we have the cost equals the cost minus the discount, and we'll print what the cost is. Remember, the cost started at $20. So let's run this and see what it looks like. Cost is $17.15 because it's on sale. Now let's change this to N. It's not on sale. That's the only thing we're changing. Cost is still 20, discount's nothing, on sale there. It's going to run this if statement. If that's true, it's going to add the discount of $2.85, subtract that from the cost, and print the cost. So let's run it. Cost is $20, because when it ran this if statement, that was not true. That was false. On sale did not equal Y because we took it off sale by changing it to an N. All right, here's our last example. The if statement, define main, print, let's go to the movies. Tickets cost $7.25. Must be going to a matinee. Snack, nothing. Now, order popcorn, input, here's an input statement. So this is going to pop up on our screen. Popcorn, yes or no? Do you want popcorn? Right? And it tells you what to enter. Don't type yes, hit Y. Don't type no, hit N. Then we have an if statement. If order popcorn equals Y, if they said, yes, I want popcorn, then we're going to add $3.75 to whatever the snack cost was previously. Whatever it was previously, which we set the cost at 0 originally. So we add $3.75. Total cost equals the price of your ticket plus whatever you spent on snacks. Right? So at print, here's the print statements. Cost of tickets is this much. Cost of snacks is this much. Total cost is this much. End program. In main. All right, let's run it. An embedded page here. Popcorn, Y or N? Let's say N. No, we don't want any popcorn. We just want to see the movie. Let's go to the movies. Cost of tickets, $7.25. Nothing for snacks because I said no popcorn. Cost $7.25. Let's run it again. Decide this time we do want popcorn. So we got to test our program on both sides. Yes. Oh, now it added $3.75, which, you know, that must be a really dinky popcorn because they're like $10 at the movie theater. So our total cost now went up to $11 because we added $3.75 in there. And you could also add another if statement. You could do another input for, do you want to drink, order candy, all that kind of stuff. And the more of these statements we add, we can put the cost, and it'll just keep totaling up. For every yes, it'll add more to the total cost, snack cost, right? So we could modify that and take care of all that. So that is how if statements work. And we'll be working with if statements this unit. That's the last page of the lesson, because then we get to page 5, which just says, make sure you read the lesson. You can practice using Python. You know, so you can go in here and change these things around right here in the lesson. You can go back to page 4. And if you want to change all of these programs and play with it right here, you can do that. Of course, if you want to start a new program, just hit idle button up here. Write your own program to practice. We don't have to write a program this week in the assignment. So if you want to practice it, open up your idle window, start writing your code here. Give it some practice. All right, let's look at our assignment this week. First time we've seen decisions. So we're just going to have a quiz over it here. Here's our questions. Relational operators compare values and determine whether a condition of an if statement is true or false. Is that true or false? I love it. A true or false question about true or false. In Python, which relational operator means not equal to? Which relational operator means greater than? Now remember, your questions may be different. There's a bank of questions it pulls from. So you may not have the exact same questions. But these are all asking about the operators. What's the purpose of using Boolean logic? So there's a question like that. And then it'll give you a statement. Which of the following if statements, this one says uses a Boolean condition to test if the item's on sale, you can buy it. So which one of those statements would be for that? Now, your question may be different, but it should be similar, just not exactly the same. But that's it. 5 questions. Pretty simple. And then next week we'll get more into that. I think we should have a program next week that we write with an if statement. So we'll get to that. All right. Any questions on that? Pretty straightforward. Just if something's true, great, do that. If it's not, do that. I mean, that's how we live our life. If it's 7:15, on an A day, I need to be in programming class. If it's not, then I don't. That's how we live our life. We make if decisions all the time. All the time. That's just, we don't write them out. So we have to follow exactly the Python way of writing if statements and Boolean logic. So, all right, guys, I won't keep you any longer. You know everything you need to know. If you want to go do the quiz now, that'd be great. If you haven't turned in last week's assignment, write that program, because next week you'll be getting behind multiple programs. So you want to get that turned in soon. So, guys, have a great week. If you got any questions, hang around, and we'll see you next time. No mandatory Friday, but I will be here if you need help.